When you're jamming to Taylor's tunes, it's easy to get lost in the words. Have you ever stopped to think, wait, how do they actually do this? How do they sync the lyrics with the song in real time? If you dug any further into this, then you realize that the whole process is less magical than it seems. Spotify's lyrics are powered by Music Match, and a human has to manually upload the lyrics and match every word or line to the correct timestamp. Notice that I said word or line since Music Match supports both word sync lyrics or line synced, although Spotify only allows the latter. Now that we know where the lyrics come from and how they get there in the first place, let's think through how Spotify consumes them. This is a sample payload containing lyrics that I've obtained by inspecting the network requests on the Spotify web player. It contains a bunch of metadata, most of which won't be useful for our purposes. So let's clean it up a bit to make some room. I'll get rid of this and this, then we can add in one lyric line. This is the most important part of the payload, and among other things, it has the starting timestamp for the line in question and the actual words to be displayed. One thing to keep in mind is that the lines are desorted chronologically. This makes our work much easier when we need to determine the current line in the lyrics. Now, how would that look like? Let's hash it out. Here's the problem. Given a timestamp, we need to determine which lyric is currently active. Now, since we know that the lines are sorted, one approach we could take is find in the first line whose start time is larger than the current timestamp. What this would correspond to is the next line. If we had its index, subtracting 1 from that gives us the current line. But what if the index is 0? Well, that just means we are at the first line. If we add that check, then that's all we need for our function here. But you know what we say, talk is cheap, so let's delve into the code. I've gone ahead and created a simple Vite React app. The only other things that I've added to this repository are the CLSX package, which will help us with composing class names, and of course, TailwindCSS. We go back here, the first thing we can do is of course render out the lyrics. I'm going to import them from the lyrics.json file that I have here. And if we inspect it, you'll notice that it's the exact same structure we have from earlier on, except now we have way more lines than we did in our example. Keep in mind that this source code can be found on GitHub from the links in the description box. Going back here, let's add the logic to render out the lines. We'll loop through each of the lines, render out a paragraph, give it a large enough text, and of course embolden them. We save that, then that actually gets rendered out in the browser. Next, we need to figure out how to sync the lines with the song. Now, our example doesn't have any media playback functionality, which is why we have this use dummy audio hook. If I open it up, then we can see it has this imaginary timestamp value that we'll use to simulate playback. And how we are setting this value, we have this set interval. We have an interval that will run every 500 milliseconds and increases the timestamp by 500 milliseconds, provided it's not larger than the length of the song in quotes. I went with this to keep this video focused on the lyric syncing rather than the actual media playback, but I do plan to make more in-depth tutorials where we'll be building things from scratch in the future. So let me know if that's something you'd like to see. Going back to this, with our trusty hook, we now have a way to access the current timestamp. I've used an arbitrary length of 178,000 milliseconds to give us enough time for the lyrics to play out. Next thing we need to do is add in the logic for getting the current line. I like to abstract things, so let's create a hook, call it useCurrentLine, and it will do exactly that. It will take in the timestamp, and we'll need a way to store the current line that we compute. This will happen in a use effect that will get triggered whenever the timestamp changes. In here, we'll plug in the logic that we discussed in our earlier visualization. We get the index of the next line, check if that's 0. If so, we know that we are at the first line. Otherwise, next line index -1 gives us the index of the current line, which is what we're setting here. If we save this, this hasn't changed anything visually yet. So let's do that now. This point, where we're looping through the lines, let's add in a variable to determine whether we are on the current line by comparing the starting timestamps. And if we are, let's use that to change the color of the text. Current line will be white, otherwise it will be black. If I save that and refresh the browser, then this should have made a visible difference, and you'll see that it does. As the lines progresses, then you'll see the current line is in white, the rest of the lines are in black. While this works, it's not exactly what we are going for. We're trying to replicate what Spotify has. And one thing that they do have on their end is that lines that are on the future are black, the current line is highlighted in white and lines that have already been passed through are dimmed or gray. We can add that. We can replicate that logic very simply by adding another variable called it isPassLine and check whether we're on a line that we've already processed. If so, then let's change the color to a gray 400. Save that, refresh the browser, you'll see it's already made a difference, but we can refresh it to make sure as it starts from the beginning, it's white. Lines that we haven't processed yet are black, and as it processes, as it moves along, it will leave the rest of the text in gray. So far, so good. Although we have one more problem. This is not animated in any way. This is very jittery. As we move along the lines, it's not flowing like they seem to do on Spotify's end. So we need a way to do that, and we can do that by adding in a reference to store the current line. This will give us a reference to the paragraph and access to certain methods on the paragraph that we'll use to scroll into the view. If we add a reference here, we can check whether we're in the current line. Use the ref we just created, otherwise leave it as null. Next, add in a use effect that will run every time the current line changes, and when it does, we check whether our ref is defined, and if so, then we know that current line ref.current gives us access to the paragraph that's the current line. Then we can call the scroll into view method with a behavior of smooth. If I save this, you'll already notice a difference. The lines seem to be scrolling towards the top of the viewport as they move along. This is not exactly what we're going for again, because Spotify seems to scroll towards the center. So the question is there a way to change it from scrolling towards the top and make it scroll towards the center? And yes, there is. We add a very simple prop, block center, save that, and now you'll notice they're scrolling towards the center of the viewport as opposed to the top. And that's actually it. It works now. The only thing that will make this better is an actual song, but I can't play that here. Although, if you hum this along in your mind, you'll see that the lyrics actually seem to move at the correct intervals. Anyway, thanks for watching. You may go back to jam into those tunes now.